And let's take a look now. How can we find the total enthalpy of a reaction using the formation reactions of the product and the reactant? So the total enthalpy can be calculated by adding up the enthalpies of formation of all the products, subtracting the enthalpy of formation of all the reactants. We have to keep in mind here that any element that is participating on it, the value of formation will be zero. So there is nothing, no energy, no change of enthalpy into the formation of the element. Formation compound, the enthalpy, the standard molar enthalpy of the formation compound can be found on the pages 4 and 5 of your textbook. So when we see this formula, this term here means sum of. And on this case means that of all the terms, all the products and all the reactants, okay? The N means the number of moles for the certain product or reactor. Of moles, sorry. So this indicates that we have to have a balanced chemical reaction, whatever it is. The change of enthalpy of formation, so change of H in standard condition, it's the change of enthalpy of formation molar, standard enthalpy of formation. And it is measured in kilojoules per mole. You can find it on page 4 and 5 of your data booklet. And this letter P here indicates that you're dealing with products. And letter R indicates that you are dealing with the reactants. And just keep in mind that any element, oxygen, hydrogen, or it's a zero. The enthalpy change of formation is zero. Okay, so let's take a look at this case that we have here. So lead and bromine are acting together, are reacting together to form lead bromide. Now, from the page 4 or 5 of your data booklet, we can find that lead bromide is with an enthalpy of formation of a negative 278.7 kilojoules per mole. And lead and bromine, being element, have an enthalpy of formation of zero. So the enthalpy of formation of a reaction will be whatever is the enthalpy of the product minus the enthalpy of the reactant. So this is a balanced equation. So 1, 1, 1 are the coefficients in front of the elements. So 1 mole times negative 278.7 kilojoules per mole. So moles and moles is cancelled out, minus 0 plus 0. And will give us negative 278.7 kilojoules as the formation. Let's take a look at this one here to calculate. Let's see the second one before we move to the first. So let's take a look at the second example. Calculate the molar enthalpy of combustion of methane. Combustion of methane reaction is something like this. Will give us water and carbon dioxide. Now, as the state of matter is gas, gas. This is a question that sometimes I get it from the students. So what is happening during combustion? A high temperature is released. As a result of this temperature, this heat is absorbed by carbon dioxide and water. Water absorbs more because it has a higher specific heat capacity, and therefore it turns into gas. Because it is important to notice that water liquid and water vapor gas have two different standard molar enthalpy of formation. When you see them at the almost at the very end of page 5, you see two values for water, one that is water liquid and the other one that is water vapor. So water vapor is the one that is produced during combustion reaction. Okay, so this is gas and this is gas. So now let's balance it. So what we will have here is one carbon, 4 hydrogen, 2 water to make it 4. So 4 oxygen to make it 4. Therefore, we go to the data booklet, and then we see methane has standard molar enthalpy of negative 74.6. So negative 74.6 kilojoules per mole. Oxygen being an element is 0. And then water gas, now we will go to the line where it's saying water vapor, will have a standard molar enthalpy of formation of negative 241.8 kilojoules per mole, and carbon dioxide will be negative, where is it? Carbon dioxide negative 393.5 kilojoules per mole. Okay, so now when we are finding the enthalpy of a reaction, then we will go and say whatever is the product minus the enthalpy change of all the products minus the enthalpy change of all of the reactant. So will be 2 times negative 241.8. This is moles, and this is kilojoules per mole. So moles and moles are cancelled out, plus 1 mole of carbon dioxide times a negative 393.5 kilojoules per mole. So moles and moles is cancelled out again, minus, this is everything that is related to the product, minus 1 mole of methane times negative 74.6 kilojoules per moles of methane, plus 2 moles of oxygen times 0 kilojoules per mole on oxygen. So moles and moles is cancelled out. So as you see here, kilojoules, everything is in kilojoules. That means that the final answer will be in kilojoules, and the molar enthalpy of the reaction after you complete the math will be negative 208.5 kilojoules. This is the molar. However, then we go to the balance equation, and we see we are looking for molar enthalpy of methane. So we take this number and we divide it by the number of moles in the balance equation that methane has. So then the molar enthalpy of combustion, it's a combustion of methane, will be negative 802.5 kilojoules times 1 over mole. 1 mole of methane. So this will be again negative 802.5 kilojoules per mole as the molar enthalpy. As the total enthalpy of the reaction for combustion of methane will be this one here. Now, what do we do on the first example? So because I said that, let's do the second first, and then we'll go to the second. But in top of this, we will do some stoic. One second. Yes.